Hello, Washington teachers. Today's PD is focused on teaching math conceptually. The outcomes for today's PD will be to deepen the understanding of conceptual mathematics, understand the benefits of using models to support mathematics concepts, as well as identify and apply best practices to support conversations around math. Let's begin the conversation today by reviewing the agenda. We will discuss the question, why teach mathematics conceptually? Then we will go into the how and the what. We will have several opportunities to reflect on questions. We will also have a moment to plan and set a goal for ourselves. And finally, I will review resources on the last slide. Let's begin today with a quote. You know, students who major in elementary education, they're going to be grade school teachers. They have the highest rates of math anxiety of any college major. And they bring that into the classroom. So you find students being introduced to math concepts by teachers who may have not only a lack of training, but also a lack of enthusiasm about math. So I want you to take a moment and reflect on your schooling. How many of you found math to be a struggle? Let's stretch that just a little bit more. Reflecting back on your math schooling, when you reached an aha moment with a math concept, what helped you to understand that math concept? You might want to get a notepad and pencil to jot down your responses. We will have additional reflection questions in this presentation. If you are lucky enough to watch this PD with your team, you will have an opportunity to reflect with your team a bit later in the presentation. Let's take a moment to pause and jot down our responses. Wonderful. Thank you for taking the time to respond. So, why teach math conceptually? Let's consider math from the past. Mathematics has always relied heavily on students remembering procedures and rules, with the occasional trick to help them calculate correct answers. With this teaching method, the focus is on acquisition of skills where accuracy and speed are rewarded. Students learn to manipulate symbols rather than hands-on resources, and there is certainly no need for discussion or collaboration. Our current math understanding is quite different. Educational research over the past few decades has provided the necessary data to shift the focus from routinely learning mathematics skills to understanding mathematical concepts. We now know that higher order thinking and creative problem solving are the new in-demand skills for the 21st century. To build these skills, students need time to develop deep understandings of concepts and, most importantly, the connections between them. In short, we must give students visual models and the opportunity to discuss their thinking so they can learn mathematics conceptually. But how? A conceptual approach requires a greater focus on teaching the concepts or ideas of mathematics and making sure students understand the connections between those ideas. For example, in the past, students would learn the meaning of the equivalence and subtraction symbols as soon as possible, since this was necessary for writing equations or applying the written subtraction algorithm. They would then use this skill to complete drills and exercise in the hope that this would help them memorize their basic subtraction facts. Now, we spend time ensuring students understand the idea of subtraction and the fact that there are, in fact, 3 different types of subtraction. In doing so, they learn that in all cases, there is always a total, a known part, and a missing part. The missing part could be the amount left, which is the type of take from subtraction. The other part would be the unknown addend subtraction, or the difference is part of the comparison subtraction. As students learn these types of subtraction situations, they make connections between these new ideas and the concept of addition, which they would already know. In simple terms, they learn how a subtraction can undo addition and vice versa. When students understand the concepts behind subtraction and the connection with addition, they then practice the skill of subtraction by learning their basic facts. Let's take a moment to reflect. What am I already doing to teach math conceptually? How does this look in my virtual classroom? Let's take a moment to pause and jot down our responses. Great. Thank you for taking the time to respond. You've heard that a picture is worth 1,000 words, and that seeing is believing. When it comes to mathematics, seeing is also understanding. Our brains are designed to process objects that we can see and that we can touch. Too often, the math children learn in school is disconnected from their experiences in the outside world. Models reestablish that connection. By working with physical and visual representations, they begin to connect school math with their lived experiences. When teaching for understanding, students need visual representations of mathematical concepts, ranging from discrete physical objects or pictures to continuous models that have attributes of length, distance, and area. In early grades, students learn the concept of fractions, for example, 1/2, using hands-on experiences with area and length models. Later, they discover they can find 1/2 of a set of objects, and they can mark a point on a number line that is half the distance from 0 to 1. As students progress to higher grades, they continue to use number lines and area models to learn about fractions greater than 1, and again, as they begin to understand the meaning behind operating with fractions. Let's pause and reflect again. What visual models am I currently using in math? Are these visual models accessible to students when completing independent work? And how does this look in my virtual classroom? Let's take a moment to pause and jot down our responses. Fantastic. Thank you for taking the time to respond. I would like to focus on the second question. Are these visual models accessible to students when completing independent work? One way I've seen this done is by creating a central location where such as Google Classroom or perhaps a page in your Canvas course, where you house or store all of your digital anchor charts used in class discussions. This is then shared with the students so that they can access the charts as needed. A conceptual approach encourages students to share with and explain to their peers the connections they see between and among mathematical concepts. This provides a necessary opportunity for students to build their understanding of concepts by discussing and justifying their own thinking and by evaluating other students' thinking in constructive and supportive settings. Most importantly, students are encouraged to apply these understandings and build upon their knowledge to think and reason mathematically in problem-solving situations that are rich and meaningful to them in their everyday life. As teachers, we must provide opportunities for students to discuss their thinking and their logic. Consider this question. Who is doing most of the talking in my classroom? Several decades ago, Flanders reported that teachers of high-achieving students spent about 55% of their class time talking, compared with 80% for those teachers of low-achieving students. So how can we provide ample opportunities for students to discuss their learning? You may consider limiting teacher talk. One model I've seen in classrooms is the 10-2 model, where the teacher speaks or teaches for 10 minutes and the students can discuss their learning for 2 minutes. So, let's reflect again. What am I doing to support mathematical language and discourse? What additional supports do my language learners need? How does this look in my virtual classroom? Let's take a moment to pause and jot down our responses. Awesome. Thank you for taking the time to respond. An often forgotten scaffold which could support math language discourse in your students, especially language learners, is providing sentence frames. These language frames will provide a structure for speaking and writing. Additionally, a visual resource of these language frames can support students in using academic language to demonstrate their understanding of the content. So why provide the language model? You may ask yourself, my students know how to talk. The language models, or the sentence frames, focuses the speaker or the writer. It can also be differentiated from simple to complex sentence structures. It also forms a mental map that will assist the speaker in becoming more proficient in their response. And finally, it gives reluctant speakers and writers the ability to be successful. So let's take a look at some examples of mathematics sentence frames, ranging from simple to complex. Beginning with simple. I solved this problem by Let's crank up the complexity a little bit. Based on I know And finally, this one's pretty complex. I used the strategy to find the answer to I know that is so that means is equal to Do you see yourself using language models in math? Let's continue reflecting. If you are lucky enough to be working with your team, I would like you to pause the video and reflect on the following questions. What is your biggest concern or struggle with math instruction? Where do you see your students struggling the most? What are you already doing to teach math conceptually? How does this look in your virtual classroom? What new strategies are you ready to try? Here is where you're going to set your goal and make a plan. And how will this look for you? Go ahead and take a moment to pause and discuss with your team, or even just jot down your responses. Fantastic. Thank you for taking the time to reflect on these questions and make a plan for your mathematics instructions. Today, we discussed why and how to teach mathematics conceptually. We also explored a variety of strategies to ensure that we teach math in a conceptual way by using visual models and providing opportunities for students to discuss their learning. We also set a goal for incorporating a new strategy. Find someone on your team to share your goal with. Have check-ins to gauge progress and effectiveness. I would like to leave you with two things. First, this quote. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. And finally, let's take a look at some valuable resources. The first resource on this page is Virtual Math Manipulatives. This will help you with having visual models for your students. The last three resources can be found in the San Jose Unified box, where you will find language frames that will help you prepare for your math lessons.